One of the reasons why algebra is important is because algebra allows you to see things which you wouldn't otherwise be able to see. So for example, the area of this triangle here is given by, so suppose the height here is A, the length here is B. The area of this triangle here is given by A, B over 2. But now suppose I were to, so this is the vertex, but suppose I were to move this vertex across slightly. Now which triangle is bigger, this one here or this one here? You see, you might have been given a formula where the area of this triangle here is given by A, where A here in this case is the vertical height here, times B over 2. You might have been given this here, but how do you know, how did the first person come up with this formula here for this triangle? You see, for this one here, we can see it's definitely A, B over 2, because A times B would give you a rectangle, and then if you cut the rectangle in half, then it would give you this. We can see that the area of this is given by A, B over 2. But when it comes to this triangle, how do you know that this is also A, B over 2? And by the way, by knowing algebra, by reading this, you can see that the two areas are, you can see that the two areas are the same just by looking at the algebra, because you know this is exactly the same as this. Then you know this area is exactly the same as this area. But the main question is, how did the first person know that this is A, B over 2? And what happens if I were to take this vertex beyond the B, so over here somewhere? Hang on. So if I were to move the vertex beyond the B here, so now which triangle is bigger? Now can you truly say that the area of this is A, B over 2? Can you truly say this? The question here is, which triangle, which is the biggest triangle? You see, by using algebra, you can see you can actually work out the area of this triangle, the area of this triangle, and the area of this triangle. Okay, so the trick here is to introduce this variable here, c. Okay, so the area of this here, so the area of this would be the height here. Let's just concentrate on working out the area of this. The area of this here would be the height here, which will be a, and then we would times. Don't forget, we would times it by c, because we defined this length here to be c. So we would times it by c, and then we would divide it by 2, because a times c would give us a rectangle here, but then we cut the rectangle in half. Then that would give us this area here. That would then give us this area here. But now we need to work out this area now. So this area would be a, the height, a, times this length here. Well, this length here would be b take away c. So if you get b here, the whole length here, b, and then you cut c away, then that would give you the length from here to here. Okay, so this length here would be b take away c, and then divided by 2, and then so this bit here would this bit here is the area of this triangle here. Okay, and then this bit here is the area of this triangle here. So you just need to add the 2 together. So now same denominator, so you can just merge the 2 together. So it would be, it would be AC plus plus this A bracket B minus C, and then now looking at this here, so what you've got here is like one block here and then another block here at the top. So now you can use this times this times this. So this would give you equals, this AC here will be here, AC, and then plus, and then this will be A times B, AB, and then this times this will be, remember there's a minus here, minus AC. And then now you can see that these two, they would cancel each other out. And then that would just leave you AB over 2. So the area of this, we now know definitely for sure that the area of this would be AB over 2. In the next video we would deal with this area here. Okay?